morning, everyone. I'd like to begin by acknowledging the traditional owners of the land on which we meet today, which for me, where I live, is the Gubbi Gubbi people. But I'd also like to acknowledge the traditional owners of wherever you may be watching from today. And I'd also like to pay my respects to elders past and present. Today, we're going to be taking a very quick look at how to take an existing Unity project that is using the built-in render pipeline and convert it to the high definition render pipeline. Now, in the interest of time, which we don't have a lot of, we've closed off the Q&A in here, but I'd encourage you to join the ANZ and SEA Unity user Discord, where you can pick up any discussions that you'd like to have. I'll share the link at the end, but I'll get Marek to also share the link in the chat, so you should be able to see that and click it and ask some questions in there. Marek might be able to hang out in there a little bit while we talk. But I'll also put it up at the end of the talk and be in there for a little bit after as well. So a really quick look at our agenda. It's pretty straightforward today. I'll introduce myself in a moment, and then we'll talk a little bit about render pipelines in Unity. I'll quickly talk about our microgame templates. Then we'll have a look at an actual demo of the process, and then a couple of links at the end. Not many. I know you can't click on them from where you are, so it's really only just a couple that are easy to write down. So my name is Adam Single. Perhaps I've met some of you before. I've been in the Australian game dev industry for about 10 years now. I attended my first GCAP in 2010, I think it was. It was the last one to be held at the Gold Coast before they all became permanent in Melbourne, back when they used to alternate. I was at the first PAX Oz in 2013. I was at the Showgrounds. I was there as part of 7-Bit Hero, which is an amazing big pop band that I'm the programmer for. And for a little over a year now, I've been a field engineer for Unity, covering Australia and New Zealand. So I'm going to go through these slides pretty quickly because I want to make sure we have enough time to cover everything else. So I couldn't find an image of a render pipeline that wasn't more complicated than I wanted. So here's an image of a gas pipeline instead, just to set the vibe. So before we can talk about high definition render pipeline, we need to address what a render pipeline is, and from there, what a scriptable one is. So a render pipeline performs a series of operations that take content of our scene and display it on the screen. Now, there's numerous parts to that process, but at a high level, these operations are culling, which is removing things that can't be seen, rendering, which is literally displaying what can be seen on the screen, and then post-processing, which is applying some extra effects across everything. So for many years, Unity had just a single render pipeline, which was a fixed function pipeline. It was general purpose. It has limited options for customization. It doesn't mean that everything looks the same. Post-processing effects and shaders can and have been used to create numerous distinct visual styles. But when it comes to suitability for different styles and hardware platforms at a performant level, it was a relatively closed box. This was actually taken from a series of excellent tutorials from a site called Catlight Coding. So if you're interested in graphics and Unity, I'd highly recommend checking it out. There's heaps and heaps on there, very detailed. So in recent years, we've introduced scriptable render pipelines, and these allow the developer to control what is rendered using C# scripts. This allows control over when or if Unity's low-level graphics architecture should perform specific graphics instructions. So it gives you a lot more control. This image is from the Boat Attack project, which is a free open source project that's built on the universal render pipeline that you can find on GitHub. At Unity, we strongly believe in democratizing real-time development, and writing C# code isn't necessarily the most user-first way to configure and customize the scriptable render pipeline. So we've built 2 scriptable render pipelines that you can use without needing to code necessarily. These are the universal render pipeline and the high definition render pipeline. The universal render pipeline, or URP, is a scriptable render pipeline that is quick and easy to customize and lets you optimize graphics across a wide range of platforms. Whereas HDRP, the high definition render pipeline, is a pipeline that lets you create cutting-edge, high-fidelity graphics on high-end platforms. So we'll look at that more shortly. So HDRP uses physically based lighting and materials, high dynamic range lighting, and is aimed at those looking to create high-end games and photorealistic animations. It can leverage latest hardware for things like real-time ray tracing, which is a computationally heavy technique for getting realistic lighting and reflections. The project that we're going to use it in today isn't necessarily a typical project for HDRP. It's just an example to show you how to take an existing project from built-in to HDRP. And that project is one of our micro game templates. It's actually we're going to be looking at the FPS template. We've provided a few micro game templates. There's more coming. These are complete projects that already have audio-visual assets in them. They've got game logic in them. They have guided in-engine tutorials, and they have accompanying course material on our education site, which is Unity Learn. I'll share that link at the end as well. So the Discord link and the Unity Learn link will both be at the end. And these projects are designed to be an exploration ground that allows you to learn Unity by modding a very small already existing game. Okay, so with that, we're going to go straight over to here. This is our presentation. Now, this has been pre-recorded primarily to cut out a lot of the load time for converting materials and textures and all that sort of stuff. So this is what it looks like at the start. I've just removed the tutorial. I skipped the tutorial. You can optionally come back to it. I've changed my layout to be something that I prefer, and we're just going to play around with it a bit to make sure I'm happy with it. Okay, and the first thing we need to do is install the HDRP package. So this is using the built-in render pipeline currently, so HDRP isn't in this project. So we do that from the package manager, which is under Window Package Manager. And you make sure that we're underneath all packages, and then we just search for Pi, which is enough, and we hit the install button. This would normally take quite a bit of time because it's doing a lot of processing and a lot of re-importing of assets. So I'll sped this up quite a bit so we don't spend the whole talk just looking at this. And the first thing that should pop up is the high definition render pipeline wizard. I should have sped this up a little more. In a new project, that would be a lot quicker, obviously, but this already has existing assets that are being converted. So here's the wizard. It's got a magic fix all button at the top, but it also breaks down all of the individual issues with your current project and why they're not suitable for the HD pipeline. But we're just going to hit the fix all and let it do its thing. It's going to create some default assets here, and now we're in HDRP. So the first thing that we can probably see is that our whole screen has gone magenta. So magenta is the color that Unity uses to tell you that there's an issue with a materials shader. In this case, it's the fact that all of our materials are using Unity's standard shader, which is part of the built-in render pipeline. And so they're not suitable for HDRP. So we can use the wizard again to automatically upgrade these to HD shaders. So again, that's going to take a bit of time. Now, currently, this doesn't work for the built-in particle shader, and we're working on that. There's fix coming for that. So for that, you would just change those manually. You'd find the materials that you're using for particles, and you'd switch it over to a HD shader. Okay, so now we have our high-definition materials, but our scene looks quite different to what we had before. And this is caused by a combination of things, which we'll fix now. It has to do with our lighting, which has now been converted to a physical-based lighting model, and our lack of a sky. So what we're going to do is remove the default HDRP profile that the wizard set up for us, and it's actually one that exists inside of the package. And so any files that exist inside of a package are immutable or unchangeable. And so when we look at it, we'll find that all of its options are grayed out and we can't change it. So we want to change that anyway. And the wizard automatically created a new one for us that we're going to switch over. So underneath our project settings, we can go to the HDRP default settings, and we can scroll down and have a look at what profile is being used as our default profile, which is this one here. You can see everything underneath it is all being grayed out. And this is being applied sort of globally to our game. And you can see here that's underneath the packages directory, so we can't modify it. So what we're going to do is change it to one of the ones that our wizard created for us, and you can create new ones yourself if you want to, but the wizard does one for us. It's called Sky and Fog Settings. So we're just going to drop that in. It's a really basic one. It's only got a couple of things on it. Okay, so we can see in the inspector here, we've got 3 overrides, and one of those is the HDRI Sky. And you can see here that it's got a cube map set on it called Default HDRI Sky. And we can also see that that is also in the packages directory. So we can't go messing around with that, all of its settings are grayed out. So we're going to replace it with a sky to match what this template had originally. So we're going to find the original background art, and we're going to convert it to a cube map. So the texture type is fine. It's still just a default texture. We don't need to change it to anything else, but we're going to change its shape from 2D to cube. And we're happy with that. So then when we hit apply, we see the icon change. And if we go to our HDRI Sky, which we can do from inside of our project settings, we don't need to go to the inspector. It's the same asset. We can drop it in, and we're now using it, but we still can't see it. It's still not happening inside of the scene yet. Now that can happen sometimes because when you first set up your project, when you're converting from built-in to HDRP, it sometimes doesn't update everything and bring across your global settings. So sometimes you need to restart your project and let it refresh that out, which is what we did here. And so now our sky is in and it's working, and our default profile settings is working. Oops. Sorry about that. Okay, so, but everything looks blown out. So that's because of our exposure settings on the sky. Basically, we're taking too much light from the HDRI sky. So we're going to bring that down to 1. And we're going to turn off the fog for now. We'll come back to looking at that later. We're just looking at the lighting at the moment. So if we go back to our profile that we did there, and we see the HDRI sky exposure, and we pull it back to 1. But our scene is looking fairly orange, and this is because the original scene was adjusting the color of our direction light to look like it matched the sky. But now that we're actually using a HDRI sky and HDRP, we don't need to do that anymore because our lighting actually pulls color from the HDRI sky, and we already get that happening for us. So we can go through and choose our direction light and choose a color that's a bit more neutral and a bit more natural. What I'm doing here is just disabling the second camera. So in this particular project, we have 2 cameras. The second camera is designed just to render the weapon so that it doesn't clip the walls. In HDRP, where in this version of HDRP, which is in 2019.4, we don't have the camera stacking support yet, but in the HDRP version 10, we actually have a very cool tool called the compositor that allows you to build up layers of rendering and using a node graph, very much like shader graph, control how those layers composite together. And that would be how we would do something like this, most likely. But in this one, we're not going to worry about it. I just want to make sure we can see our post-processing. So we're just going to render the everything on the main camera. Okay, and then I think we fix our direction light. We're going to go through and change the color of this orange to something a bit more neutral and let the HDRI sky do its work. And you can see that our lighting in HDRP gives us some U values, some more natural values. So we can control the temperature, we can use lux values to be able to set the intensity. And in fact, the lux is pretty low on this one. Oh, first I want to show you quickly how the lighting changes based on the HDRI sky. So I've pulled in a couple of other HDRI cube maps that are from the asset store. They're just our Unity ones that we put up. There's 7 skies that we've put up on there. And as I switch them out, you can see how the lighting changes to pull from the lighting in the sky. So it can have quite a big effect without having to actually try and change the color of the light itself. So we'll switch it back, you see it has a big effect. Okay, so I think we'll look at the lux values. If we're looking at realistic lux values and we look it up online, we can see that a midday clear sky is normally somewhere around 20,000 lux. So we can go in and we can set our direction light to that value. Messing the cameras again. Before we get back to direction light. Okay. So if we set this to 20,000 lux, which should be a natural value, this is like a bright midday sun, we can see that it doesn't look quite how we would expect. It's quite blown out, but that's okay. The reason is we don't have any exposure set up in our profile. So if we go back to our sky and fog profile and we add a new override for our exposure, we can control how the camera reacts to realistic lighting. So at the moment, it's just defaulted on fixed. We can set it to automatic. So automatic will actually, in this case, it's using a center weight. So it's looking at the middle of the camera and judging how much light there is, and it's using that to decide the exposure. And if we look at the sky, we can see it changes brightness a little bit as we move around, depending on where we're looking. But it's not affecting our actual scene light. And that's because the HDRI, the visual environment itself is set to static. So we need to change that to dynamic. And now we can see it's starting to work. And the last issue is our HDRI sky itself has its own exposure value and it's too low. We need to bump it up. So we're going to push that up to 10 and we should find all of this balances out really nicely. So I get distracted by the chat there. So we change our HDRI sky, we bump up its exposure, and this should all balance out naturally. And what this will actually give us is the ability to dynamically change the exposure based on where we're looking relative to the natural lighting. So this will give you that effect of walking out of a building, for instance, and into a bright outdoor scenario where you get that sort of flash or brightness of light while your eyes adjust. So that's what's happening here. Okay, so let's look at the next thing. I really don't want to run out of time here, but we're going to move along. So we're going to look at decals really quickly. Decals are a great way to break up repetitive patterns like we have on our walls here. I've downloaded a few images from this excellent site called cc0textures.com. They don't have a massive selection, but it's all quite quality stuff. And they've got a category for surface imperfections that has handprints and coffee mug rings and scratches. I'm going to use one of those for a decal. So we just create a new decal from the game object menu. It's just underneath the rendering tab that we just saw. We just position it so that the z-axis is pointing at the surface that we want to project our decal onto. We can use the orthographic view and the boundary handles tool to size it perfectly where we want it. I'm just going to skip ahead here so we don't run out of time, but I'm just sizing the decal to fit over that wall. And then we are going to create a material that's going to go onto our decal. So at the moment it's using a default one. We're going to create a new one. We'll drag in one of the images. So I'm putting it here next to the images that are downloaded. And we're just going to drag on one of the scratch transparent one there and put it into our base map. And then we assign it to the decal. We need to make sure that the shader that's being used is the HDRP decal shader, not the lit basic one. And when we resized the decal, it automatically changed the tiling and the offset. So we're just going to revert that back to 1100 so that it stretches out over the whole surface. And you can see that we have our decal now being projected onto the wall. So decals can be used like this as sort of breaking up a static environment, but they can also be used for more dynamic things like bullet holes, blood splatters, other aspects that can be generated at runtime from gameplay. All right, now just to demonstrate some reflection stuff, I'm going to do something crazy and just put a big mirrored ceiling in the next room. So I've just created a cube. It's just a game object. From the game object menu, you can just go 3D cube. I'm just going to resize it and position it up around the roof until we're all closed in. And then we'll create a new material for it. We're going to set the material's metallic and smoothness up to 1 so that it's just completely reflective. Okay, and at the moment it doesn't reflect anything. Except for the skybox underneath. So we're not getting the room, we're only getting the skybox underneath. So what we want to add here are screen space reflections. So we need to do that in our sky and fog settings profile. We'll add it in. And it tells us that our HDRP asset doesn't support screen space reflections. So if we go to our HDRP asset, which we can find from our project settings, so it's at the top of the graphics tab, if you don't know where it is, and that'll point you to the right one. And if we select it and scroll down, we'll see that underneath reflections, screen space reflections isn't enabled. So we'll hit enable on that. And then we can enable it in our profile. And we'll see that we do get something happening. Now, because this room is so tall, the screen space reflections can only work with roughly what the camera is seeing. It can only reflect what's inside of the camera view. And this is where ray tracing can help us. So with ray tracing, we can bounce a lot of rays around and get a lot more realistic reflections around what the camera can actually see. So here we're just going to add in our ray tracing. Now this has some hardware requirements, so that's all in our HDRP documentation, but we can use our wizard again to set it up, and the wizard will tell us if we don't have the resources to be able to do this. It'll still come back with a failure here at the end, but you can still run the wizard and see what happens. But basically, if you've got the right graphics card, you should be able to do it. And DirectX 12. It does require an editor restart, and this does take quite a bit of time. But it's going to go through and do a whole heap of computations. It's going to create some new assets, and it's going to restart the editor as it switches to DirectX 12. So now I can enable ray tracing underneath my screen space reflection. This option didn't exist before, but now that we've updated it, it's there. We can see here that it doesn't quite get it all. That's because of our ray length. So we boost up our ray length so that it's the rays are long enough to bounce, and we have this sort of very mirrored image where you can't even see where the two meet. Now, obviously, there's going to be a computational expense to doing this. Ray tracing isn't necessarily cheap, so you would be very selective about when the right time to do it is. But when we're talking about something like an architectural visualization project in a small room, then you can definitely use this to your advantage on key areas. So you can see here I've added a little bit of noise to it by bringing the smoothness down, and we can put on our denoise, which is an option inside of our settings that'll help take a lot of that noise out of the way. Yeah, I don't want to spend too long here, we're running out of time. Okay, so this is our boss room. So try and do this real quick. We've only got a few minutes. So this is our boss room. What we're going to do here is we're going to add a sub volume, I guess. We have our default profile set up in our project settings. That's happening across everywhere. So anything we set inside there is going to happen everywhere in our scene. But now we're creating another volume that is just a smaller part of our scene, and it's going to be a local volume. So you can see in the inspector, the mode is set to local. At the moment, it doesn't have a profile, so nothing's being overridden. But we can create a new profile from here, and then add overrides that override the default only inside of this space. We can play with the weight distance and the blend modes for how much that happens, but by default it'll just be sort of a zero blend and a full weight. So you walk in and it just sort of switches from one to the other. So in here we're going to enable some fog, and what I didn't realize right now is that in my scene view I don't have the fog enabled. So the fog is happening, but in my scene panel here I can't see it, so I'm going to switch it on. Okay, so now I've got fog happening inside of this volume. It's only happening inside of this room. I'm going to change the color a little bit. I'm also going to add a chromatic aberration, which is just a post-processing effect. I'm going to crank it right up just to mess with the player as they walk into the room. Again, I've forgotten that I don't have the post-processing visible in my scene view. So once again, it's working right now, but I don't have it visible. So that'll click for me in a second and I'll go and fix that. And you'll be able to see the distortion that's happening around the edges, especially of the screen. And you get this sort of color bleeding out. So this will happen to the player as they walk into this room alone. So we can override and build atmosphere in very specific areas. Now I can use something called a density volume, which is kind of like a profile volume, but it's like a subset of one that's just for fog. So if you've got volumetric fog already set up, then you can use a density volume to create a sub area of it that has more density in it. So I'm going to use that here just to build another layer of density in this fog just inside of the square that the boss is in. So I can change its color a bit. I think I even make it a weird purple color. Make it really thick. Okay, so this is, the boss is in there somewhere, there he is. Okay, and what I want to do here real quick, this is the last thing I'm going to do, so we're nearly out of time, is add a spotlight on the boss. I want his eye to sort of glow and light up the fog. So I want this volumetric light happening inside of the fog. So I just added a spotlight. I'm going to crank its intensity up to some crazy number. I'm messing around with values for a little bit before I remember about the lux value at. So when I'm under a lux value, this at value defines how far away you get the full value, and then it falls off quite quickly. So in this case, you'd have to be a meter from it to really see it, which is why it takes me a little while to figure out why I can't see this light. But as I get closer, I can see it here. And so I can move that up value further out, so you can see it from further out, and then I can crank up the volumetrics multiplier. I can start to play with its shape a little more, and you can see how it really nicely lights up the fog. and then we hit play to watch it move, and it doesn't because I attached it to the wrong object. So I quickly figure out where the right object is. And you can see this glowing red eye now. I think when I deselect it so we don't see the, that's better. And there we have our volumetric lights inside of the pod. So I know that was super fast. The half an hour seemed to disappear very, very quickly. This is barely a toe in the water. We have heaps more resources online. There's more resources at Unity Learn on HDRP. We have our Discord, which you can go in and ask questions about. We're happy to have discussions in there. There's also a lot of content about the microgame project that we had here. So on Unity Learn, I actually have this up for you. So this is a link that you can find on Unity Learn just by looking up the FPS microgame. And you can see there's a whole heap of tutorials and content on taking this project and modding it and adding some new functionality and learning how to make games in Unity from little snippets of mods here. So there's probably a solid weekend's worth of tutorials there, and then you can go off and make whatever you like. So thank you so much for your time. Thank you to Screen Victoria and Melbourne International Games Week for having me today. I know that was a really blitzed coverage, but hopefully we'll see you in Discord and we can have a chat and answer some questions there. Thank you.